All right, this is recording number 2. My director, Tiny Keller, gave me the cue to get started on part 2. So this is part 2. We're going to be doing a review session for tomorrow's sprint challenge, blockchain and hash tables. So does somebody want to pull up the sprint for tomorrow, and then we can just kind of like read the readmes and try to game plan an idea, not necessarily give answers or anything like that, but just kind of game plan, same way we would if we were meeting for another module and we're trying to game plan so people aren't wasting time doing something that they thought they should be doing. And so yeah, let's do it. Thank you, Tony.
Sure.
And by the way, I think Brian mentioned in lecture, but so a lot of people are going into this thinking, because it's a hash table and blockchain sprint challenge, and the idea is that if you go into it with the mindset of, okay, I'm just going to work super hard on this blockchain, I'm gonna get my miner going, I'm gonna get so many coins, but like that's only, I think, I don't know, it's significantly less than like the interview questions. The interview questions, if you do well on all of those and you don't even mine one Lambda coin, you'll still pass. You'll still average like a 3, I think, on the sprint. So I will say, don't put all your eggs in one basket. Don't put all your coins in one wallet. Set yourself a timer to work on the miner, and then after that you can work on the review questions or the interview questions, and then go.
Wait, I'll share again in 1 second. I have something running and I don't know what.
Okay. No problem.
Divided into 3 parts.
Yeah, so I'll have the solution up, and then I can give you guys clarity if you need.
Are you going to be the one pulling us aside? I said, are you going to be the one pulling us aside?
Pulling you aside for what? Oh, for the interview questions?
Yeah.
I'm not sure. They didn't mention anything today in our stand-up for that. They just said that that those would be worth more. I'm surprised that they're still. Are they doing that now? Like where they have?
I'm sorry. What's worth more?
The interview questions. So like on your sprint challenge, you'll have like a part where you do you create like a miner, and that's what what's his name was bragging in the channel last week during, I don't know, sprint challenge or whatever, build week or whatever, and he's like, hey, I don't know, you guys gonna catch up to me. I've been mining coins since yesterday, and we'll be mining coins forever till next week. So yeah, those interview questions right there. Okay, so yeah, we are pulling you aside, I guess, right? Okay, cool. I don't know if it's gonna be me. Maybe it will be. But we can go ahead and we can discuss these. And I mean, I can't give you the answer, but we can discuss them, and I can lead you in the right direction.
Looks like you're right too. It's three out of the 5 interview questions. So
yeah. So he said, I mean, like, don't focus too much on the miner. I mean, it's nice if you can get a coin, but yeah. All right, so let's just go over, what do you guys want to go over first, the hash table part or the blockchain part? Doesn't matter, just pick one.
Can we do hash then?
Sure. All right, go ahead and if you want to read that in your most beautiful voice there, Tani, that'd be awesome.
For the hash tables portion of the sprint challenge, you'll be working through some algorithm problems that are amenable to being solved efficiently using a hash table. You know the drill at this point. Navigate into each exercise's directory, read the instructions or the exercise laid out in the README, implement your solution in the .py skeleton file, make sure your code passes the test by running the test script with -v. The hash table implementation has been included for you already. Your task is to get the tests passing by using the hash table. You can remind yourself of what hash table functions are available by looking at the hashtable.py file that is included in each exercise directory Note that the hash table implementations for both exercises differ slightly.
Thank you, in that most beautiful voice. Okay, let's go into exercise 1 directory and we'll check that out first. I don't know if it's just me, but I feel like I understand things better even when I hear it. Like I'm reading it along, but Tiny's reading it out loud and it just registers better for me. All right. Maybe we can have somebody else read the next one. Let's go. Anybody? Jade? Jade's coming from the kitchen.
Sure, it's just going to be a little noisy.
Okay.
Starting from reading merging two packages.
Sure.
Given a package with the weight limit and a list weights of item weights, implement a function, get indices of item weights, that finds two items whose sum of weights equals the weight limit. Your function will return an instance of an answer tuple that has the following form: 0, 1, where each element represents the item weights of the two packages. The higher valued index should be placed in the 0th index and the smaller index should be placed in the 1st index. If such a pair doesn't exist for the given input, your function should return none. Note, when calling hash table retrieve with a key that doesn't exist in the hash table retrieve will return none. Your solution should run in linear time. And then there's examples. Do you want me to read the hints or?
Sure. That'd be awesome. Thank you.
Sure. Hint number 1, a brute force solution would involve 2 nested loops yielding a quadratic runtime solution. How can we use a hash table in order to implement a solution with a better runtime? Second hint, think about what we can store in the hash table in order to help us to solve this problem more efficiently. 3, what if we store each weight in the input list as keys? What would be a useful thing to store as the value for each keys? And then lastly, if you store each weight's list index as its value, we can then check to see if the hash table contains an entry for limit weight. If it does, then we have found the two items whose weights sum up to the limit.
Wow, those are some nice hints right there. I tell you what, it almost like progressed. Like the first hint is like, you know what, like let's make this better. And then the second one's like, you know, we should store to make this better. Let's store this. And the next one's like, well, what would you store as the value for that? And then the last one, you know, like, oh, maybe we should store this as a value. So, does anybody like? Oh, so what's unclear? What do we need to clarify in our understanding phase of the?
I'm confused. So it has like you have 2 lists of weights, and you have a limit, or
let's see. Does anybody can anybody weigh in on that? Otherwise, I'll draw something here. So I actually got like a code challenge like this for my interview with iFit, which is the company that makes, I don't know if you guys have ever gone to a gym and worked out with a machine called Free Motion before. It's like a cable machine, like you could do like crossovers like this, where like they're on pulleys up here and you're like pulling arms down like that. But anyways, yeah, it's a very similar problem to this, and except let's see, I think the problem was like you need to send a box of Skittles to like some clients or something. Like you have big bags and you have small bags. You need to figure out like the number of small bags and big bags that you would have that would equal like the limit in which you can ship in one box. So like like I think in this problem right here, let me just click on this.
Do you want this?
Oh yeah,
or
perfect. Thank you.
Okay. Sorry, I just stopped sharing so we could see the whiteboard.
That's okay. I can pull it up on my screen and then you guys can see it.
Okay,
then you can
better.
see me share in there if you want. Yeah. Okay, so merging two packages. So says given a package with the weight limit. So we're imagining that we have this package and there is a limit here. Let's just say the limit is 20 pounds. We'll just say 20. 20 pounds. Can you guys see that okay? Better? Okay. Then what's it say next? And a list weights of item weights. So you'd have.
I'm still going for like a minute, but I'll be right back. Sorry.
Okay, no problem.
Yeah, I'll be right back.
So implement a function get indices of item weights that finds two items whose sum. Okay, so this list, let's just imagine that the list you're given, let's go with Skittles. I like Skittles. Does anybody else like Skittles? The
I love
purple
all
bag.
candy.
The red ones.
The red ones. I like the purple bag. Okay, so here's our box. We're trying to ship grandma some Skittles. We need to figure out from this list that they give us of different sizes, weights, I guess, of these bags of Skittles. Let's say we have a, I don't know, 2-pound bag. We have a 4-pound bag. We have a 15-pound bag. We have like a 8-pound bag, and then we have a 5-pound bag. Can you guys see that? All right, then it's saying implement a function, get indices of item weights that finds two items whose sum of weights equal the weight limit. So which one out of these, which two items would add up to the limit if these are all pounds?
The 15 and the 5.
Yep. So then it says your function will return an instance of an answer tuple that has the following form. So so it needs to be returned in tuple form. So that means parentheses, right? And then so what does it say about which item needs to be in which index?
Larger should be at the 0th index.
Larger
Smaller
should be
at
0th.
the first.
So then what would go in that 0th index for our example here?
15.
Yeah.
Okay. And then the other one?
5.
5. Cool. So that's what we have to return. And what are we going to return if nothing in this list adds up to our limit? So what if this is like, say this is like 4
None.
or 3? None? None of those add up, right? Okay, yeah. So then we would just return no Skittles, Grandma. Sorry. And so it says your solution should run in linear time. So if we do run this with a brute force solution, 2 nested for loops, because what you're going to do is you're going to get this list in array format, right? Like this. And basically what you're doing is you got the 2, you got the 4, 15, 8, and 3, right? So what do we usually do when, or why would we need a nested for loops? Like what's the whole point of having the nested for loops? What does it allow us to do?
Compare 2 items in the same array.
Exactly. So that first outer for loop would iterate over what items, I guess, or I guess no, it would iterate through the same items. You're right, Catherine. Yeah. So like the first outer for loop would iterate through each of these items, and the inner for loop would iterate through every other item for each iterated item from the outer for loop, I guess.
Yeah.
Does that make sense? Yeah.
Yeah.
You guess. Okay. You know that. So that would be quadratic time, like they're talking about. So O of n squared. So what? So they're talking about the hints here. So how would we make it faster? How would we make it O of n time based on their hints?
They want you to save, I think, the weights as keys in a hash table.
Okay. So we'll come here. So hash table like that, right?
Yeah.
So they said they want us to store the weights, right? Okay, so like let's say we go through and we check this first one, right? We're checking 2-pound Skittles bag, and we're like, well, we don't have anything in here. So like what should we do with it?
Wait, what?
So like when you say that, so you said in the hint, it says that we should store the weights of the bags, right?
Yeah.
So then what would be like a value for that key value pair if we're going to store like, so if I'm going to store this 2 in here, right? Because I don't have any objects in here. I don't have anything to compare with.
I would just store the key and the value is the same.
So you do like this.
I think. I don't know.
What do the rest of the hints say?
I'm not reading them, so I can't.
Oh, can somebody like weigh in on that, please? That's funny. I said weigh in because these are all weights. That ching. That ching.
It says we can store each weight in the input list as keys. What would be a useful thing to store as the value for each key? If we store each weight's list index as its value, we can then check to see if the hash table contains an entry for limit minus weight. If it does, then we've found the two items whose weights sum up to the limit.
Okay, so based on that, Obeda, what do you want me to put as a value here?
The index and the thing? What?
Read it again. Read it nice and good.
What if we store each weight in the input list as keys? What would be a useful thing to store as a value for each key? If we store each weights list index as its value, we can then check to see if the hash table contains an entry for limit minus weight. If it does, then we've found the two items whose weights sum up to the limit.
All right, so check this out. So when we do a for loop, right, the first for loop, the first for loop is going to look at this item, and the inner for loop is going to compare this item to every other one, right? So it's going to compare it to this one, this one, this one, and then that one, right? Then it's going to move, the outer for loop is going to move in to the next index, and it's going to compare every item except that one that we're currently on, right? So if the whole point of using two for loops is to be able to compare two values, like what are you essentially doing when you're comparing those values in terms of the limit? Like what are you trying to figure out when you're comparing these two values?
If it equals 20.
If it equals 20, right? So if you know that and you want to make it faster, what can you do ahead of time that will allow you to check the value for something to see if it does equal 20?
20 minus the limit minus whatever the weight is, and then you test to see if any of those numbers equals the difference between.
That's what I'm talking about, beta. So yes. So what he's saying is, so here, right, like when I'm comparing two and I compare it to 4, I'm saying is 2 plus 4, is that equal to 20? And it's not, right? So then I go to the next one. 2 plus 15, does that equal 20? No. So instead of doing that with the for loops, you're taking the hash table and you're doing this. You're doing 2 and 4, and you're saying, actually, you're doing one at a time, I guess you would say.
2, 18.
Yeah, you store 2 in here
So
as
you
a
say
key.
20 minus 2.
Yeah, so you're doing the limit. Oh man, I can't give you
minus the weight.
Like
so it's like 20, 20 minus 2.
So it'd be 18, right?
And then the next, yeah.
Yep, and then you go to this next one and you're like, yo, 4. Like, okay, I'm gonna go over here and I'm gonna look at the cache or at the hash, and I'm like, yo, is there anything in there that's 4? Like anything that has a value of 4, right? Because you're gonna go through each key, all the different keys in there, and then
so
if it has
sorry.
Go ahead.
Wait, so you're saying the keys are basically the weights themselves, and the values are the weight minus, or the limit minus the weight?
Correct.
Or I guess the difference between limit and weight. Okay.
Yep. So you're like pre-calculating what you would normally do with the nested for loops, but you're calculating ahead of time. And then like what you're doing is you're comparing every subsequent weight to see if like the anti-weight of it exists already in there as a value of a key. Or I'm sorry, I'm sorry. If the weight equals any of these values, right? So like 2 would have to be paired with 18. So like when we get to 5 and or 15, let's pretend this last one is actually 5 again. The last weight is 5. So we go 4, There's no 4 in there right now, right? So we're gonna put 4 in there, and then we know that 20 minus 4, 16. So we store 16 in there, and then we're gonna go to the next one, 15, and we say, okay, so 20 minus 15, right?
Wait, so are you matching the value of one basically to the
I'm
key of the
sorry.
other?
Yes. We're taking
Okay.
this and we're trying to match it to any of these values that
key.
exist. Yeah.
Wait, so so for example, 15 would then be a key, and the difference would be 5. So then you're looking for something with a key of 5 because you know
exactly. So then like you get to 8, right? And then 8's not in there either. So then you store 8 in here, and 8 and 12 go in there. Then you get to the last item right here, 5, and you come here like, yo, is 5 in here as a value? Oh, it's right there. Boom. That much faster. That's O of 1 runtime.
Guys, there's no way I would have figured this out.
No way that I would have known this.
Time.
I wouldn't have known this had I failed
runtime.
a channel. Or what's that? Go ahead.
I still don't get how that. I am not understanding the runtime stuff. I feel like you're just doing almost 2 for loops differently. I'm not getting how this is faster.
So you're taking you have a list, and then you are taking that list and putting it as a key and setting the value to the key to be limit minus the key.
The difference, yeah.
Different, yeah.
Mm-hmm.
And then, so you're.
Go ahead.
So you are doing a for loop,
but with an object.
With an wait. Well, are you looping through the list to make a hash table?
You are looping through this list, right? And you're saying yes. You're saying if it doesn't exist in here, like after you've like calculated it or whatever, then go ahead and add it as an entry. And what do we know about insertion for hash tables?
Is 1.
It's O of 1, right? What do we know about deletion or even like search for hash tables?
It's faster.
O of 1, right?
Oh yeah.
O of 1, right? So so you would have O of n runtime when you're using a hash table, because the O of n comes from the for loop that you have to iterate through for each of these.
It's still linear.
Right?
Oh, so then you're checking if there is a key or a value that equals an item in the list.
Yes.
Wait, what is that? What did you say, Catherine?
Well, like, so when you're like looping through a list, and then like, you know how like we'll have like a list, like we did like a list, you could do like how we had that names project where you could store like and make an object and like loop through one of the lists. You could just be like, so you like do a for loop for the length of the list, and then check if item at I is in
the binary search tree.
Yeah, but then like if you're making a dictionary, you can check if a key, if it's in the thing.
Exactly.
But then the key or value, do you have to do enumerate?
No, actually in JavaScript, I remember you can do something like if key in, and then you put the name of the, actually you put if key in object dot keys, and then you put your object. Okay, yeah, so you can't do that in Python too. But in Python, it's more like, it's more beautiful looking, right? It's like,
wait,
100%.
Yeah.
Wait, so so if key.
If you'll have to look it up, but it's object.keys, I think is the method. And then like whatever you would put inside of the parentheses here, that's the object that you're trying to traverse through and like see if that key is, if it's in there, if it is a key or whatever. But then like you'd have to get access to the values. So I think there might be even something called if k comma v in object.keys or object.values. You guys will have to look that up, but I don't remember the syntax for that, but I just know that you can do it. You'll have access to that. So Obed, are you still unsure about the runtime for? Like,
no, I guess I get it. Because I was thinking linear like O of 1, but O of n is linear.
Yeah. Yep.
Yeah.
Oh, one constant. Yeah.
Yeah.
Tani, Jade, you guys feel like you're clear on like what they're expecting you to do here?
I'm not sure.
Okay.
So like, oh wait, what are we actually doing with this?
So we're gonna get a list. They're gonna
Turn
have
an
a list,
answer.
and we're gonna loop through the list. And as we loop through the list, we're going to check if there's a key or value in the hash table. And if not, we're gonna create a new thing in the hash table. And then when there is a key or value, when there is a value in the hash table, then we know that is that those two weights equal the limit.
Okay. So like, let's say that let's say like we have skittle weights and we have limit, right? So your function would need to take in what? How many expected inputs are there to your function then?
2.
2. What are the 2?
Limit and weight.
Yeah.
Or wait.
Skittles. Weights. Why did I make that variable name so long, yo? Okay. And then what's this data type gonna be?
An integer.
Yeah, oh, if you're doing Python, right? Okay, and then this one?
A list.
Okay, and then expected output, how many?
A
1.
tuple.
Oh,
Huh?
yeah.
How many?
Tani was right, 1, but I just
Oh,
said
sorry, I didn't hear.
Oh yeah, it's a 1, but then I was like, it's a tuple.
Specifically, yeah. She's right,
Okay.
though. Specifically, it's a tuple,
Okay, cool.
which will contain 2.
Okay, cool. And then, so we know that much. And so like if we did a brute force way, it would be a for loop, because basically you're checking to see, like, you're basically gonna do like limit minus that weight. Or I'm sorry, you're gonna use the double for loop to compare each item in the list to other items until you find one where both those items are equal to the limit, right? Like you're looking for 2 pairs that are gonna match, right? So I'm comparing everything to 2, and then after that, I'm gonna compare everything to 14, right?
And then you're returning the indices.
Mm-hmm. Yeah. So
okay.
yeah. So these are gonna be stored inside there. They're gonna be
So then
indices.
okay.
Not the values themselves, but the indices. So then that will also influence what you store inside as a value, for your keys, right? Yo, it says it says that you want to store the indices as the keys. Go ahead. What?
The indices as the keys or the weights as the keys?
I did the weights as the keys because the code challenge that I did for iFit, they had me, like, I used the Skittles weights, the bags. But here they want you to use the indices because you're going to be returning indices in your output, right? So like if you find a match in the object, but you only like have like the value, like you still have to search then. Like you have to take that value or that weight, search the list for it, and then find what index it's at, right? So like you might as well just store it as an index.
Well, could you store the index and the value, like as a tuple, like the difference and then the index?
Yeah, you probably could. Yeah.
Wait, so what would that look like? Sorry.
No, you're good.
Go ahead, Catherine.
Well, I was just thinking, because the way you had it before made sense with like checking the keys and then having the difference. But you could keep the index and the value, like you could store the index as well. You could just store it, the value could be a tuple, and it could just be the index is at 1 and then the difference is at, or the index is at 0 in the tuple and the difference is at 1 in the tuple.
Yep. So what Catherine is saying is, like, you have your, let's call it, we'll just call it cache, right? Because that's what it really is, just a cache. Okay, so first one we're going to do is we're going to take this 2, and because remember, you don't have 2 for loops anymore, you can only iterate through one item at a time. So that's where the limit comes into play. So you're gonna come over here and you're gonna like look at this first, and you're gonna say 2. Is there any item in my cache that has I guess a value equal to 2? And if so, then what is the index of that value, which would be the key, right? But then Catherine is saying it would be stored as a tuple or tuple as you said the weight?
The weight could be a key. So the weight could be the key. If the 2 is, if it's a key, if there's no key, then you can make it, and then you could store the difference and then the index that you were at as.
Got you. Okay. So like this. So like, yep. So we look at 2, and then what would be stored inside of that?
That would be 0 and then 18.
You could also store it in the next linked list, right?
Mm-hmm. So that would be the difference, right? The second number in Catherine's tuple would be a difference, and then I guess the 0th index would be the index from this list.
Yeah.
Right. So does that make sense now? Jade's probably cooking still. Jade, are you cooking?
I'm everything's in the oven, so I can.
Okay, cool.
Chime in. So then it would. So we'd be basically returning the actual index. So it would be 1 and 2. That's 14 and a 6, right?
14 and 6. Yep.
Yeah. So we'd be returning index 1 and index 2.
Yeah. And you'd have to return it the way that they wanted it, which they want
largest at 0th. Yeah. Okay.
Yeah.
So do they want us to return the index from this or the index that's in the hash table?
The index from the list, from the original list,
that
right?
they're giving us. Okay.
Yeah, but you can store the index in the list in the hash table.
Right, as one of the items in the tuple, right? Right here, index from list, right? So the next one we'd be looking at would be 14.
Wait, I'm sorry. So can you, an example answer then for this problem?
So you walk me through it, Tani. So like we just went through, this is the first one we looked at here, right? And like we're looking at it and we're automatically going to go to the cache, the object, the hash table, and we're going to compare. We're going to say, is there any key that has a difference of 2 in here? And then you're going to be like, no, there's not, because there's nothing currently in the cache. It's empty. So then we're going to make an entry for it. So we added it in there. And now, like, let's say we go to the first index. What's the first thing we would do next?
So you would check if there's any other key that has a difference of 6.
Yes. Sound a little more sure, Tani. Like, you know.
No, I'm just having a hard time. Like, I know the concept, but I'm having a hard time. Like, I think I'm just super fatigued. But I'm having a hard time with like what the syntax is.
Don't worry about the syntax. As long as you understand the general idea, you can always look up the syntax.
Syntax is always what gets me.
Me too.
Yo, as long as you know Google, I mean, you can have Google. You're gonna be straight. Trust me. You can look at all your old code too. Like, come on, like that. It's just knowing the game plan. That's
no, because this is why I don't finish my sprints on time, because I can't figure out the syntax. It kills me.
That's what Google's for, though.
I was Googling the past few sprints.
You could probably actually Google this answer, but that doesn't help you though. Okay, so like let's say we got 14. We're looking at that, and you said that we're gonna come over here. We're gonna have 14. We're gonna compare it. Is there anything inside of this cache object that we have that has a difference of 14. So like it obviously be included in the value, Catherine's tuple here, right? And there's nothing. So what would we do, Tiny?
Create it.
Okay, so what do you want me to make as the key?
That'd be 14.
Okay, and your tuple?
So the value you would put in the tuple, and it would be 1 and 6.
Nice. Okay, next one. Then we come over here. First thing we do is what, Jade?
So we're going to do comparison
Mm-hmm.
for 6. And we do see that the value is there for the 14.
Ding, 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 ding. So then what do we do then?
So then we need to grab we know that's our match.
Mm-hmm.
And so then we need to grab the indice. Well, wouldn't we want to compare first which one is larger at the indices, or should we?
Well, you can just grab this value and store it in a variable, and then you can do what you need to do down there, because Catherine so nicely put it in a tuple for you there.
So then we can just grab that indice, put it in our tuple that we're going to return, and then find the indice that which, if it's being stored, we can just grab that and just see which one's bigger, the 14 or the 6.
Yeah. Actually, you guys think it would make sense to, right off the bat, like when you grab one of these items from the list, you automatically note, like you have a variable set up or whatever. I guess it'd be a for loop. So it'd just be I, right? As you're iterating through there, like I would be equal to the index that you're currently comparing. And then like once you find the value that it's equal to, then you grab that index, set it equal to a variable, and you compare those two down here. So this is value 1, this is index 2, right? Like, is it less than? Yes, it is. Okay, so then I'm gonna put 2 on this side and then 1 over here. There's the answer. Return that 2 and 1 like that, right?
Well, wouldn't it actually be 1 and 2? Because 1 has to be, the 14 has to be at the 0th index. Or did I misunderstand?
Yeah, no, you're right. I'm sorry. I was comparing the indices. We're comparing the values, right? Is that what it says in the hints?
I'm not sure.
It says the higher valued index should be placed in the 0th index.
A higher valued index. So then when you're just looping through, that would just be the item at I. That I would always go at the 0th index, and then the value stored in the object will always go in the first, because you're looping through. And the indexes are going to increase as you go through. So you know that when you're going through your list, and you're comparing the stuff in the object, that the thing that you're getting and comparing from the list, that's going to have a greater index than the stuff that's in the object. Because you're creating the object as you're going through the list.
Right. But I'm still unsure of whether or not you're comparing the value of the index or the value of the array at the index.
Oh, I don't know.
Right. So like what Jade is saying is, Jade's saying, are we comparing the 14 and the 6? Or are we comparing the 1 and the 2?
It doesn't seem clear.
Even if you compare the, if I'm understanding, even if you compare the 14 and 4 after you subtract it, the leftover, if it's lower
hey guys,
than...
I'll be right back. I gotta put my daughter to sleep, but you guys keep going. I'll be right back. I'm coming. All right.
Okay.
Continue, Beta. You were basically saying, since we're doing the comparison in the hash table, we're always going to have the biggest one as the key and the smallest. Is that what you're saying?
Almost. So you know how you have 14 and 4, right? So 14 minus 20 will be like 6, and 4 minus 20 will be 14. So whichever number is smaller when we're comparing, and we find it, whichever number is smaller will then be the one that goes first, or goes second. The index goes second.
Okay, so you're just saying whatever smaller, put it there?
Yeah. So like we would do like an if else, I guess. It would be like once you find both, you can get the key value pair, and then whichever one has a smaller second number, if that's the value, that one would have their index be first, if I'm making any sense.
What does it mean higher valued index?
It's a good question. I thought it was comparing the higher number.
Is that
Well,
then
is it
the high?
the weight or the actual index?
See, that's the part we're trying to sort out. I don't understand because it just says
I was totally off.
function will return an instance has the following form. Each element is the weight.
We can look at the test.
Oh, wait. This is the code, I think.
Mm-hmm.
Oh, wait, let me see if
there's
there's another.
Yeah, there is. Yeah.
Oh, that's it.
Even with going over this stuff like tonight, it's still gonna take me like 5 hours.
Yeah, same.
Same exact example they just gave us. Okay.
How we doing, y'all? We're done
Still
with this problem?
trying to figure it out.
4, 9.
Okay.
You guys are done with this, right? We don't need this anymore.
I don't know.
There's no 9 in the array.
Be like
I think it's the
9.
higher index. You all are right. If you look at the last one, number 4, index 6 is 0, and then index 2 is 6. I mean, is 7. Sorry. And so you all are right. It's the higher index, not the higher weight.
Higher
Then
index?
you're always
Okay.
gonna know that the thing will be the thing because
Yeah,
you're
so-
going through it.
Yeah. So the current value that you're iterating through, that's the one that will go in the 0th index.
Yeah.
Yeah. Okay.
Wait, so I'm confused. So wait, so what does that look like? So an answer example, which index goes in there? Like which is
The
it?
highest one goes at the first one. So like when we had the whiteboard with like Tico's thing that he has, like so you have a list and you're doing a for loop through the list, and you're also as you're looping through, you're also creating your hash table. So you're gonna be as you're creating the hash table, the indexes are gonna increase as you're going through.
Mhm.
So you know that when you're like have your item at I, your weight at I, like in your list, and if you find that in your if you find a value in your hash table, you know your item in your list is going to have a higher index because the hash table is like that thing was created before. So you know you can put the item from the list, that index, in the first position, and then you have the index stored for that item in the hash table that you can put at the first position, or the 0 and then the 1.
So it would be his bottom tuple there.
Yeah,
Yep.
2 and 1. It's always going to be
How
like
can you see that? I can't even see that.
Sorry.
yeah. So
You know what might be better is if somebody opens a replit and then they do an example of the replit in there, and then we like pseudocode along with it, and then that way everybody would have access to that, like the
But
steps
do we
and
mean-
stuff. You want to do that? If you want to do that, I don't know.
So what my question is I don't know why I'm not making this leap, but like for our answer, is it, so we're, okay, so the index that we're talking about is when we say 2, we mean the number 6. So I was
Correct.
confused on whether it would be like the index for the number 6 or
Yeah,
6
no, that's
itself.
right. You're
Okay.
returning.
I wasn't sure if it would be 6
Yeah.
because
Sorry.
we're setting that as an index or as a key. Like,
Yeah. Well, I mean, they tell you in the hints that they want you to store the index as the key, but Catherine, she likes the idea of storing the weight because it's just easier to conceptualize in your head. You're taking this and you're comparing it to the different weights because this, like, it would naturally more translate to like the values that would go in the keys, because these are like the index or the values in the list, the original array. But yeah, I mean, in the hints, they're telling you to actually store these. They're actually telling you to store them like that, and then have this just be the difference or whatever. But then that would change what you'd be comparing to. It'd just be more confusing, but Catherine's idea is actually better, because then you can actually see what's being put in here.
Can we do a replit?
Yeah, you want to open it up? Or, I mean, is everybody okay with that, or you want to move on to the next one, or?
I actually have to hop off.
Yeah, I have to
Okay.
eat soon.
Yeah, same. That's why I have to go get food.
No problem, yo, no problem.
But I will be back on later tonight. So if anyone wants.
I will probably be off, but I have a recording ready for you.
All right. I'll watch the recording.
All right, guys.
Yeah.
See you all
Thank you guys.
Monday.
Yep.
See ya. Good luck
See you guys.
tomorrow.
Yeah, you as well. All of you.
All right, so Tani, you want to open that up? We can go over that. I need to hop off in like 13 minutes.
Was that this is besides the Bitcoin and the questions, it's just this hash, or is there a couple different? Because I haven't had a chance to look at it yet.
Yeah, let me see here. Let's see. Make sure. Okay. Let me share my screen. Okay. Yep, so we have inside of the sprint challenge, we have blockchain and we have hash tables. Make sure you run your pipenv install, and then your pipenv shell. You can see you have the pip file and the pip file.lock there. So we went over the first exercise in hash tables. So that was this one here, merging two packages.
Okay, so there's a second exercise.
So breadcrumbs. Second exercise, one-way flight trip. So actually, I remember this one. This is a HackerRank problem we did. But we can go over this one. What do you guys want to do? I got like 12 minutes. You want to pseudocode this one, or you want to try to knock out the replit for the other one, Tani?
I don't know.
I would like to at least get try to wrap my head around this second one.
Okay.
At least get some feedback, but that might be
I guess
more helpful.
maybe we won't even need to do the replit. Tani, I guess what's your question? If we can answer directly, both Jade and I maybe can provide like different angles.
I'm not sure. We can just go over this one, the second one.
Okay. Let me. Okay. All right. I could probably find you a resource and drop it to you. Oh, you know what? You guys have access to this. So actually, this is really good. Okay, so if you go to, I want you guys to go to your, let's see. You're gonna go to your dashboard, and you're gonna click on this little link here, GitHub Student Pack. And if you don't already have Front-End Masters membership, you get it 6 months for free just for being a Lambda School student. So you'll click this the GitHub Student Developer Pack, make this bigger. And you'll scroll down, like notice all this, you have access to all this cool stuff just for being a student. So like a ton of this stuff, like a whole year for free. Like, are you kidding me? Look at this. Data Camp, Dat.tree.io, GitHub Campus Experts, Typeform. Like, this is a way to do like forms and stuff. Let me see, let's find this thing though. Front-End Masters. So Front-End Masters is like a super professional version of Udemy, made by developers for developers. There's a course on here. So you'll just click this. It'll ask you to verify your student account status using your GitHub. But yeah, you'll get 6 months free. And so you guys can do that on your own. I'm going to show you the exact video that will explain this whole memoization thing for you and go through an example. So Tani, then I wouldn't have to go through the replit with you, and then you could just go through that. All right. Let's see. Bianca Gandolfo is her name of the author. Right here. So it is a practical guide to algorithms with JavaScript. Yes, I believe it's this one. So you go to this one. You're going to scroll down. So you notice you have, they talk about like space and time complexity, big O notation, even some more stuff on space complexity.
There it is, caching with memorization.
Yep. So like, I believe it's these four together. So like, yeah, it's this one, this one, this one, and this one. Like when you do those together, actually, no, the first six, I'm sorry. You won't even, I don't think you'll need this closure one, but yeah, these first 6 videos right here, if you watch those, you will, it's like crystal clear what she's doing. She explains it probably way better than I do. This is where I learned memoization from. So that should be good. Is that cool, Tiny? So like,
yeah.
I'll just, yeah. Yeah, I know you guys can't hear that because I didn't click the option to share the sound, but you know that. All right, so let's go over this one-way flight trip. So somebody want to read this, this read me out loud, please?
I can read it.
Okay.
You've booked a really cheap one-way flight. Unfortunately, that means you have tons of layovers before you reach your destination. The morning of, you woke up late and had to scramble to the airport to catch your first flight. However, in your rush, you accidentally scrambled all your flight tickets. You don't know the route of your entire trip now. Write a function, reconstruct trip, to reconstruct your trip from your mass of flight tickets. Each flight is represented as a class with the following form, where you have a source and a destination, where the source string represents the starting airport, and the destination string represents the next airport along your trip. The ticket for your first flight has a destination and a source of none. The ticket of your final flight has a source with a destination of none. Pseudocode for an array of tickets might look like this, except for your very first flight will have a source of none because you're starting there, but have a destination, where your last one will have a source but won't have your destination.
Mm-hmm.
Okay, so your function should output an array of strings with the entire route of your trip. For the above example, it should look like this. So we're kind of sorting it in order.
Mm-hmm.
Is what it sounds like. Your solution should run in linear time. You can assume that your function will always be handed a valid ticket chain as input. All right, hence, the crux of this problem requires us to link tickets together to reconstruct the entire trip. For example, if we have a ticket, it's probably like San Jose and Boston, that has us flying from San Jose to Boston, then there exists another ticket where Boston is the starting location, Boston to JFK. We can hash each ticket such that the starting location is the key and the destination is the value, key-value pair. Then, when constructing the entire route, the ith location in the route can be found by checking the hash table for I-1th location.
Okay. So let's just go up here. Let's ignore the hints for a second. What is your understanding of of what we're trying to do? What's our objective?
Our objective is to make sure each ticket, the kind of the connecting thing is the destination of the previous ticket with the source of the next ticket, to make sure those actually match. So like in their example, San Jose going to Boston is your previous ticket. Your next ticket needs to be Boston to JFK, and that destination and source need to match.
Right.
The strings need to match.
Good. All right. So like, what does that remind you of? Like data structure wise?
Linked list.
Exactly. Right. Because you always have a next pointer, and yeah. So like, Tani, let's where would I, like, let's conceptualize this. I got to get on a ton of flights. Like, the source for my first flight is what? I'm gonna stop sharing here so you guys can see my whiteboard.
It'd be better if Jade answers questions right now. I'm a little behind. I was looking at something else.
What do you mean? It's okay. Like that. That's the whole point of this.
But you only have a few more minutes.
It's all right. I mean, like, just.
I would rather we get like the information recorded, and I can rewatch it.
Okay.
Okay. So your first ticket, your source is going to be none.
Okay.
Because that is your starting point.
Right. So actually, let's start with what a ticket looks like. So a ticket will always have
a source and a destination.
Source and a destination, right? Okay. So then using this as a template, right? Our first ticket looks like what?
Your very first ticket, the source is going to be none.
Okay.
And then you'll have some destination. We'll just say like it's San Jose.
Okay.
SJC.
Okay, San Jose. All right. So then our last ticket.
We'll just say it's JFK. Make it small.
Last ticket. So the source
will be JFK.
Okay.
And then your destination will be 0 or none. Sorry, none.
Okay. So immediately, like when you start, when you iterate through that list that they give you, so they're going to give you like, what is that? Oh no, it says your function should output an array of strings with the entire route of your trip for the above example. So yeah, like you said, yeah, you're going to be sorting basically, right?
Mm-hmm.
So you're iterating through the item that they're giving you. And then you're also creating a new array to output, right?
Yeah, your array is going to have all of the airports and starting from the first one to the last.
Okay. So does that make sense, Tani?
I'm sorry, I was not paying attention.
Okay. Because I feel like I want you to understand this too, like not just from the recording, but like in real time. Okay, so just like looking at the tickets array, Tani, in the example they give us, like what's the first thing we should look for in that list? Like if we're going to look for our first ticket. So we know that our first ticket source is going to be none, destination is going to be some airport. We know the last ticket is going to be JFK, or have a source of an airport, and then the destination is going to be none, because you're not going anywhere once you get to San Jose, you're done. My question is, what do you want to look for to find the first ticket?
So basically, you need to see if there's a value of none in your first ticket, or the source equals none.
Mm-hmm.
And that'll give you your starting point.
Right.
So you're going to iterate through all of those and find one that has that as your beginning.
Mm-hmm. So, so you're basically like, let's pretend these are your tickets. You need like let's say this is like a previous, and this would be like pointing to the next one. You need this to be none here for the first ticket, and then by the time you get to the last ticket, you need to have this point to none, right? So then by the time you're finished, your output will just be an array like we talked about
Of all the airports.
of all these airports, right?
Mhm.
Like the ones that these arrows going this way, and then just this last airport here, right? So yeah, just be an array. Let's pseudocode really quickly. Oh crap, okay. So step one, we're going to iterate through the array of objects they give us, right?
Yeah. It's going to be the key objects by source.
Is it going to be an array of arrays? Or is it going to be an array of...
Well, it would need to be an array of objects, wouldn't it? Because you're going to have each ticket has a key and a value.
You're right, yeah. Yeah, it's made with the class up there, my bad. Okay, so we're going to iterate through the array of objects. Okay, and then what next?
We're going to need to get to the objects and find the object that has a key per value of source and then the value none.
Okay. So first, find the key value pair with a source
that equals none.
Equals none, right?
Mm-hmm.
And this is going to be equal to our first ticket.
Yeah.
Right?
Mm-hmm.
And then what are we going to do with that once we find it?
Well, I think it would be the easiest thing would be to grab the destination from that first ticket and iterate through and try to grab the compare it to the source of the next ticket. This is where I'm a little confused or trying to still figure it out.
Sorry, that's good. That's a good idea. I would do that, but also think about your output. So your output is going to be an array. Maybe you might want to declare your
declare that in the first in the 0th position of the array, grabbing the wait, if it's source
grabbing that value, right?
Yeah, grabbing that, yeah.
So let's say I guess this would be 1B, 1A, declare, I'm sorry, not declare, that's for functions. Initialize an array called, what do we want to call it, Jade? Tickets,
yeah.
Or we can call it trip tickets.
Yep.
Trip tickets. Okay. And then, so after you got that first ticket, what are you going to do? You said you're going to take that destination from there, right?
Yeah. And
you're going to store it in there, right?
Yeah. The only problem is we know that's our first ticket, but that destination just tells us where it's going. It's not telling us where we're coming from. You would have to get the second ticket to see exactly where that source is from.
You're one step ahead of the game. Look at you. Okay. So then we're putting that aside then. Okay. So then let's keep going with what you were saying because you were right.
So then we're going to compare to make sure the destination of the first ticket equals the source of the second ticket. So we need to iterate and find the actual source and compare them.
So iterate through again then? So you would iterate through again after you found that first ticket?
Yes.
Okay, so this would probably be, would it be the same or different for a loop?
It would probably be easier if we're doing hash tables to put it in a hash, wouldn't it? So that
Yeah,
way,
that's right. I'm sorry. Yeah.
yeah.
I'm
So
thinking,
then we would basically take our first ticket and put it in the hash.
okay.
That way it's there and we can always go back to compare it.
Good call. What would you store as the value then for that, for the key? So we're creating a cache object. Store. Was the same thing in the hints about what we should be storing?
I don't have it out in front of me.
Let's see. The crux of this problem requires us to link tickets together to reconstruct the entire trip. For example, if we have a ticket SJC BOS that has us flying from San Jose to Boston, then there exists another ticket where Boston is the starting location. Okay. We can hash each ticket such that the starting location is the key and the destination is the value.
Oh, okay. So that way we have both. Instead of getting rid of the source and the destination, we have just both, and that links the two. So the source is key, destination. Okay, that makes sense. So then basically we're going to store this first ticket.
Okay.
And we're going to put those. This is where it gets tricky. I get that, because can you put a key as none?
I'm not 100% sure on that.
That's the only question, because then you would have your key as the word none, the string none. And then your destination would be, like, say, if we're doing San Jose to Boston, Boston to JFK, your destination would be Boston.
Yeah, why not? Why can't we store it as a string, right?
Yeah, because it's just strings. It's not a data type. So you would just put your...
Store first ticket as a string, right?
Yeah, as a string. So then it would be none, and then we'll just say our destination was Boston. And so your key is none.
So your first ticket as string key, sorry.
No problem.
Store first ticket as key.
Yeah, the hint was to store the source as the key, so that would be none. And then your destination, we'll just say it's Boston.
Store first tickets. Source. Sorry for the bad handwriting. Source as the key, and then destination as the value,
as the
right?
Value. Yep.
Which would be.
I'll say Boston.
Boston.
Yeah, using their example. A shorter version of their example. All
right.
So then it sounds like we'd be looping to grab. Let's see. Then we would need to loop to find, because our for loop is actually just going through them. It would make sense so that we can get them all in order. It would make sense to just then look for your values and look for one that matches Boston as a source.
Okay.
Because this destination is already going to be Boston, then we need the next ticket. To know it's our next ticket, the source has to say Boston on it.
Right. Okay. So I'm just trying to think ahead here. So even if you had, so when you run this for loop, right? You say like this is just a single for loop. You're going through, and the first thing you're going to do in your for loop is you're going to want to find the first ticket. That's like actually the first thing you want to do. Even if you had another for loop that iterated through the remainder of those tickets minus the first ticket.
Yeah, minus one, yeah.
That would still be O of n runtime, because you're still iterating through, because that would be like n plus n, right? Like if you have two for loops that are not nested, you have n plus n, which is 2n, but then it simplifies down to just O of n runtime, right?
Yeah. So your first for loop is just doing the job of finding your first one. And then you have a second for loop that's not nested, and that'll help you actually connect.
Okay.
At least that's my first read through of how to do it.
That is correct, actually, now that I think about it. Okay, so second for loop iterates through remaining tickets to match what?
We need to match the value in our cash.
Okay, so remaining tickets to match, to find a match,
With
find a matching value. So actually you can, so inside that second for loop, even if you even if you were iterating through the keys of the object, I still believe that's O of 1 runtime. So if you nested, even if you nested that in there, it'd still be O of n, correct? I believe that'll still be O of n, since it's just O of 1 runtime. And then even if you were squaring it, it'd be O of n, like, or multiplying it, O of n to the 1 power is just
O of n.
Yeah. So you could nest another, just like we had shown in the Skittles example, another, like, I guess it would be, it has a for keyword in there, but it would be for key in object dot values or whatever.
Because that one's actually going to do the rest of the searching. The second one is going to do. The other one only runs the one time to get the.
Yes. Yep. Just
okay.
to get this.
Yeah.
Yep.
Okay, that makes sense.
To get the first ticket. Then the second one is going to be the one that's going to be iterating through the remainder of the tickets, now knowing the first ticket. And then within that, you might have a second, I wouldn't call it a for loop. You're iterating through the keys of the object to find a matching source. Right. Find a matching source. And so you will always want access to the last object or item in the. Sorry, go ahead.
I was thinking we're always to match, because your destination always matches your source to go next. So then you would have to match the value in our cache to the source of the ticket.
Right.
That source value. And that should actually take care of, without having to worry about this last destination being none, I believe, it would be able to, unless you use it somehow as a check, it would be able to line everything up one after the other, because you're always just checking those 2 points.
Nice.
That makes sense.
Yeah, that makes a lot of sense. Okay, so you're iterating through the remaining tickets to find a matching value or matching destination for the source, you said, right?
You're looking at the ticket's source value.
Source.
To match up with our value in the cache that we've made.
To find a
of the
matching
previous
value
ticket.
In the cache of previous ticket. Right?
Yeah.
Okay. So what would that look like? Let's erase this here. Okay. Man, I'm way late. All right. Quick example and then
okay. Yeah, I don't want to keep you. My food's almost done.
Okay, so let's say our tickets look like this. We have an array. Let's put the 3 tickets in there. So the first ticket is an object. It's going to have a source
of none.
And it's going to have a destination.
Destination, just put BOS for Boston.
BOS for Boston. Okay. There's our first object. Second object.
It's going to have a source of SJC.
Source of SJC.
And then we'll put a destination of JFK.
JFK. Okay.
And then our third, make it short, our source would be SJC. Oh, did I do that right?
SJC. Oh, no,
No, it would be Boston. Sorry. Wait, did I do that right? Or San
yeah,
Jose?
we need something with a destination of none, right?
Yeah, so then our destination would be none, but our source would be Boston.
Okay.
Because
Yeah.
the second ticket was coming from San Jose.
Gotcha. So source would be Boston here. Destination would be none here.
None.
And then destination here would be.
Well, no,
SJC.
no, that second one, that would be SJC.
My bad.
Or JFK, sorry. That destination there would be JFK.
Right here, JFK?
Yeah. And then the last destination would be none. And the source is still Boston.
Right here?
Yep, because our second ticket was where we were coming from, which is, yeah, so that's how it would look.
Okay, so looking at that, so this is the first ticket. Okay, this is the last ticket.
Last ticket, yep.
And this is the
middle ticket, the second ticket.
Okay, so how does this one connect to this one? If source is SJC and the destination is JFK?
Because our source, we came from I'm looking at the first ticket, we came from San Jose.
Okay.
Am I looking at it wrong? We're going from San Jose to Boston.
Okay. Oh, all right.
I might be looking, oh, wait, no, then the source of,
your function string array strings, for example. Wait a second. Your source represents the starting airport, and the destination string represents the next airport along a trip. The ticket for your first flight has a destination with a source of none, and the ticket for your final flight has a source with a destination of none. So I don't think you ever actually know like where you start from. You just know where you're going.
Where you're going and where you're coming and going.
Yeah, because your source, you just know your source for the first ticket starts with none, right? So that's what I was thinking, like this, in order for this to be the second ticket, the source would have to be Boston, right? Like if our source is none, we get on the airplane, we're flying to Boston, like this has to be the next ticket then, because the source is Boston, right? Because this is like a previous and a next, previous and a next, right? Or am I thinking this wrong?
I thought of it as wrong because I thought your previous is your source, your next is your destination.
That's how it's, that's how I was thinking of it. So like, so let's do like previous.
Next.
So like the first ticket.
But you never know your current. That's the thing. You never know your current. So I figured the reason why I was saying that your source is none, your destination is Boston, because currently you're in San Jose with this first ticket. Like you're coming from the San Jose airport. So then your second ticket, your source, where you were coming from, or your previous ticket is from San Jose, but your next destination is JFK. You're currently in Boston. That's how I was looking at it, because we don't have a current.
Okay, well, I just got super confused here.
Sorry.
Hold on one second. My understanding was it was that it's like this. Let me just see if
I also don't have, let me sign in because I actually don't have this up in front of me.
Okay. So my understanding is it's going to be like this. Okay. Ready for this? Okay.
I'm getting there.
Oh, okay.
I'm opening up. Okay, go ahead.
So previous is your source, and then next is your destination, right? So our first ticket, second ticket, third ticket, and fourth final ticket. So no matter what, the first ticket has to have a value or a source or
Okay.
previous of
I see.
none, right?
I see. Yeah, so your destination will always match your source.
Correct. So then if we had Boston here, then the next ticket's source would have to be
It has to be
Boston.
Boston. Yep.
Right,
I
and then-
misunderstood it. Yeah.
No problem. You didn't have the repo open.
Yeah. So then
J-
JFK would
Yeah.
go up to your third ticket source.
Mm-hmm.
There we go. Okay. That's where I was getting confused.
And then if we had like San Jose here, right? That would be
Yeah.
San Jose here.
And then your
And then the
destination is none.
destination would be none. Exactly.
You've arrived. Okay.
Okay.
That
Cool.
cleared it up.
All right. So knowing that we have those in there,
Mm-hmm.
the first thing that you would iterate through is you'd have to iterate through every single one of these. And in that first iteration, you're looking for whichever
source
ticket has a
none.
source of none. Yeah. So
Mhm.
you're looking for tickets at the array, at the index of I, that has a source of none, right?
Mm-hmm.
So this would be equal to like source, none, and destination, Boston. So then how would we get access to that? Could we just chain on here, dot source?
Yeah, that would be easiest.
So then our conditional would be something like if tickets at the index of
Of
I
I dot source equals none.
source equals none, but then we need a double equals there. Then do whatever you want to do, right?
Yeah, you want to take it or push it, append it to the cache that we're going to create.
Okay, I'm just gonna pseudocode it.
Yeah.
Add it to the cache.
Mm-hmm.
Oh, I spelled cache wrong. Add it to the cache. Okay.
Yeah.
So then after you do that, then you'll start your next for loop, right? Because the first for
Yeah.
loop is mainly just to find the first ticket.
Mm-hmm.
And then your next for loop, you're going to iterate through. And then what are you looking for? How are you looking for things?
So in our cache, we've put a key pair value where your source is the key and your destination is the value.
Mm-hmm.
So you need to compare your value
Mm-hmm.
of your cache to the source in the tickets array of object.
Exactly. So then that for loop is going to iterate through the remainder
Mm-hmm.
of that tickets list.
Yeah.
Tickets list. And then it's going to, you want to have a conditional that's going to say what? If tickets
Mm-hmm.
at the index of I. Dot.
We would destination,
That,
Yes. Because if we're
destination.
coming from the list, or,
Yep.
no, is it destination or source? It might be actually source. Sorry, it's source because we're coming from the tickets list.
Okay.
Yeah, so it's the source
Mhm.
is equal to our cache's value.
Is equal to our cache's value.
Yeah,
So,
because that value is the destination.
right. Okay. So yeah, that's where you'd want to have that's where you would want to iterate through the
Mhm.
keys of the object using what object.values or object.keys.
Yeah, object.values.
Mhm. Then you get access to the values, and then
And then
would-
you can do the conditional comparison.
Yes. Cool. That's good, right? That's
Yes.
all right. Good. I hope that helps some people tonight.
I know it helped me.
Good.
I will be drawing stuff tomorrow, so that helps.
And it's 8:55. All right.
Yes.
Okay.
You gotta go.
See you guys later.
Yep, see ya. Thank you.
Yep. Thank you.